Welcome back, everyone, to another episode of Tavora Talks. I am your host, Cash, joined as always by my co-host and partner in cybercrime, Matt Mosley. Matt, how you doing? We made it through another week of cybersecurity.
Yeah, we survived the weekend. No hotline calls, thank God.
Well, no, I think there was like a hotline call, but it wasn't a serious, enterprise falling, crumbling kind of hotline call, I
Right,
guess.
right. No ransomware, no multi-continent attacks that we had to take care of. So we're good.
We're good. But we do have a good topic today, and all these things, hacks, vulnerabilities is a big thing, right? Every hack has typically behind it some kind of vulnerability. So with that, we actually uh, have a great guest that we want to talk to today about this exact topic. So I'm gonna set it up. Gentleman here, join with us. I like to do my little like hype, right? I don't want to give away everything right at the beginning, but he has helped hundreds of companies fix, tons, thousands of these vulnerabilities. And he has a book, right? He's the author of Hackable: How to Do Application Security Right. And with that said, further introduction, Ted Harrington. Ted, thanks for joining us. Welcome to the show.
Yeah, guys, thanks for having me. Pumped to be here.
Pumped to have you with us. I'll kind of just pass it to you. If you want to give a little who's who about yourself to the audience, the two people that are listening to us, and we'll kind of get the ball rolling. Let's talk about these good vulnerabilities and whatnot.
Yeah, well, as you mentioned, I wrote this book called Hackable, and it's drawn from experience of what I do with my everyday life, which is lead a group of ethical hackers, and basically we're the good guy hackers. So I get to live every day working with companies who have software that they're building, and they want to understand how it might get attacked and what to do about it. So that's kind of me. That's the viewpoint that I have, and I'm sure that will be revealed through the course of the conversation today.
Perfect. Yeah, similar background. That's how kind of I started. So
Nice.
Awesome. You're definitely in good company. And then I migrated in an instant response. So now I'm on call 24 hours a day. But welcome, Ted.
Don't envy you that.
Yeah, for sure. So yeah, we have between Cash and I, we have a lot of experience with application security. So hopefully we can have a pretty good conversation here. So the book Hackable, I looked at the table of contents and kind of skimmed through the pages here, but I really like how it's laid out. First, you talk about kind of the right mindset, picking a good security vendor or partner to work with, someone that's knowledgeable in the space, and then kind of going through and picking the right assessment methodology. So while I know what that is, and some of us that work in this space know what it is, why don't you kind of walk us through what you mean by picking or deciding on what the right assessment is? I think you talk about scoping and kind of figuring out what the client wants.
Yeah, so maybe if I can put this into context, I can first explain why I wrote the book, because I think all the things that you just pointed out will it'll make sense given the context. So as I mentioned before, I lead this group of ethical hackers, and we're in this fortunate position that we get to help, these major companies, and sometimes not major yet, sometimes they're just funded startups that no one's ever heard of before, as they try to build these, secure software solutions. And one thing I noticed this thing happening where no matter what the characteristics were of the company, geographic location, maturity of the organization, how far along they were in whatever round of funding, what industry niche they were in, it sort of seemed like everybody has kind of all these same problems with when it comes to securing their software systems. And I thought that was really interesting once I observed that. And then as I started thinking about what are the conventional solutions to, like, how do you solve those problems? That was the thing that really made me want to write the book, because I realized that the way that people talk about solving the security challenges today, that's pretty much wrong. In many cases across the board. And so I wanted to write a book that sort of corrected that, and that addressed these really common prevailing misconceptions and said, okay, well, most people think this, and instead it should actually be this other thing. And here's why that is. And here's a story, and here's some data, and here's what you should do instead. I really wanted to not only change people's mind, but also give them something to go do with that. And so the one that you pointed out, of which, there's 10 chapters, and each chapter sort of addresses one of those primary areas, about methodology. The common misconception there is that when it comes to security testing, most organizations, still today, it kind of blows my mind that this continues to be the case. People are still really attached to this idea of what's called black box testing, which essentially limits information between the company who's building the thing and the security company they've hired to help them secure it. And it's all based on this misconception that says, okay, well, I want to know if I have vulnerabilities. I want to be able to fix them. And so I'm going to hire somebody to try to emulate the attacker. And if they can find something, that means the attacker could find something. And if they don't find something, the attacker won't find something.
Right.
That assumption's incredibly flawed, because what you're doing ultimately is you're testing that security company. You're not testing your product. And most people don't realize that. They don't realize that's what's actually happening. I like to use this metaphor. It's like, let's say imagine a medieval castle, and there's a king, and the king wants to know, can his enemies kill him? And so he tells one of his nobles, send a bunch of your knights and see if they can break in. And so these knights come over, and the king doesn't tell them anything about how the castle works. So the knights, they actually spend time researching things that the king already knows. For example, there's a moat and there's alligators in it. What do they have to do? They have to literally spend time counting alligators. The king already knows how many alligators there are. That doesn't help the king at all. They're just wasting time. And when we think about the fact that attackers have sort of endless time, endless resources, and the defenders, we have limited time and resources, we have to squeeze the maximum opportunity that we can, the maximum advantage we can, and information is one. So the case that I make is why instead of black box, instead of withholding information, we should be sharing it. And we should be collaborating very closely between the companies building things and the companies trying to find vulnerabilities in them.
Yeah, that's a great analogy. I think, I've done network pen testing and web app pen testing and all that good stuff. And I always thought it was hilarious when a company would come to me and say, we're not going to give you our IP addresses. Like, you have to find it. And you're like, all right. I mean, I'm just going to burn hours that you're paying for me to find IPs that, as an attacker, I don't really care. I could either find your IPs or not find your IPs, and I'm just going to move on to the next guy. All I'm looking for is vulnerabilities to get in, or, a way to get into whatever systems I can find so I can monetize and make money off of my hack. Right. So I think that's great. I think that is a good point, that you're really, if you're not willing to open it up and do a white box test, right, not willing to share information, you're really just testing that company's ability and how good their pen testers are. And their pen testers might be garbage. We don't know, right? Like, they may not get past the first wall in the castle, but another team might get past the first wall. And so that's a really great analogy. Good job.
Well, and to build on that, I agree with you. I want to make sure that someone might hear what you just said and say, oh, okay, well, let's just make sure we hire somebody who has good pen testers, and then still do black box and they'll get in. But even the good testers are going to run into the same issues where they just can't do as complete of a job. And if we extend that same metaphor out, it's like, well, what's better? The king saying, see if you can break in the castle, and if you can break in it, maybe that tells me something. Or the king walking you around the castle and being like, oh, there's 17 alligators in that moat. Here's the schedule of the guards walking around on the turrets. Here's this tunnel that I have in case we're under siege that I can escape. And then the knights can be like, let's talk about that tunnel real quick. And immediately they're narrowed in on where maybe one of the most biggest areas of weakness can be. And that's just so much more powerful. And
but I feel like there should be like a little bit of both worlds, right? Because if the king may not know all of his tools or may not know where all of his problems are. So I feel like, maybe have him show you, or like the company disclose, hey, this is what we have. This is what we're working with. This is what we know, to make your, speed up your process, to Matt's point, right? So I don't just sit there, burn hours. But at the same time, I feel it's up to a professional to also go beyond that and say, oh, this list I got from you, we've gone through it. These are the issues with what you have. But beyond that, we, also found all of these other vulnerabilities that you guys may have not known. Right. So in my opinion, I think that it needs to be a mesh of both worlds.
Well, what you're saying is 100% true. Yes, that it's not the organization hiring a security company typically does not know all of their problems. Actually, they typically know very few of their problems. And it is incumbent upon the security company to come in and be able to take the information they're provided and expand upon it. What I'm saying is that, well, the information sharing that needs to happen are things like we need to provide any sort of architecture documentation. We need to provide access to engineers to ask clarifying questions. We need to explain the workflows and explain the business case and talk about the roadmap and how things are changing. And then, yeah, the security team has to be able to take all that information and translate it into what the actual testing is. They shouldn't walk in and be like, tell me what the problems are, and then I'll hand you an invoice. Like that, of course, it's not going to be that.
But do you think it's the responsibility of the person to disclose this? Because some people they're not very good communicators, right? They may not know exactly what to disclose. So possibly the professional coming in should have thing of this is the information I need to be
100%
shared with me.
Right.
Yeah. And I mean, I think that starts with the scoping stage, right? Is, you know, asking those questions and finding out the information you need, finding out the different roles that the application might have or different sets of permissions. You know, like whenever I did pen testing, you know, you come at it from different angles, right? An admin account, regular standard user account, maybe even a guest account. And you kind of see what areas of the application you can get into based on those different sets of permission or roles. And I think it's up to that client, right, to provide that information. I shouldn't have to go in and try and create an admin account, right? That would be one of my tests for my standard user. But at the same time, please provide me an admin account so that piece of the application can get revealed, right, during the testing. And we're not scrambling. When we write our report, we leave that whole section out. Right? So,
yeah.
But yeah, no, I think we're on the same page, Ted. I think that's like I said, I think that's a great analogy. I think it's good starting point. One thing that you touched on also was one piece of the puzzle, or a couple pieces of the puzzle, which is vulnerability scanning or vulnerability assessments, pen testing, and then some other avenues. And I want to kind of, if you could describe the difference between vulnerability assessments and pen testing, because I think I wrote a blog about this in 2012 and we're still having this conversation, right? Like people still don't understand the difference. But also, what are the other pieces of application security that you can mix in there to kind of give that layered approach? I know you talk about it a little bit in your book, so not a little bit, but a lot.
Right. So the question you're asking is about the distinction between these different testing types?
Yeah. And then what else can you do in addition to, you know, vulnerability, pen testing, and secure code training, SDLC?
Endless. There's an endless list of things that you can do. Yeah. The problem with that chapter that I was trying to tackle head on was this idea that, penetration testing, putting that in air quotes, it means a specific thing, yet it's come to refer to so many things that are really not pen testing at all. And so now what happens is the nomenclature, the actual words we use, become so muddy that the people talking about it, whether they're selling it or they're buying it or they're verifying compliance against it or whatever, like all these people are like, I don't know if we're all talking about the same thing. And that's a real problem, because each of those parties has a sort of different viewpoint and a different motivation around these different things. And so when you think about the person who buys this service, their motivations might range from, hey, I really want to build a better, more secure product, all the way to just someone told me to do this thing. What is the minimum that is the thing that sounds like this word?
Yeah.
And then there's we just want to check the box. And then there's everything in between. And some people are like, I don't care what it entails. Just give it to me. I don't want to see how the proverbial sausage is made. Just give me a sausage. You know, that's how they're thinking. And so I totally get that. But so what I wanted to do was to tackle the fact that the way that we talk about security testing is bad, because one of the things that's really happened right now is penetration testing, which is a pretty manual effort, and it has a very specific, narrowly scoped approach to it. That term is often used to describe vulnerability scanning, which is something that is way less effort, it's way less expensive, but it's something really, really, really different. And so put yourself in the shoes of the buyer, right? They're like, well, I was told to get a pen test. This one is $5,000. This one is $75,000. They both say pen test. So I'm going to buy the $5,000 one, because they're like, they don't want to pause. I mean, the onus, the problem on that is not on the buyer. They're like, look, I asked for a thing. 2 different people came with 2 different prices. They say they're the same thing. So, okay. But it is a real problem, because then they're not getting what they want to get.
Right. Yeah. I mean, I've spent, weeks on a pen test, and then at the end, the client's like, Yeah. So are you guys done with your scan?
Right.
You're like,
Really,
well,
yes.
there was a
Yes,
little bit
we're
more
done.
involved, but yeah, thanks. Thanks for watering it down. So,
The scan results did finish.
yeah.
We'll send you a CSV file.
Yeah,
Right.
exactly. Call it a day. But yeah, no, I think just the manual part of pen testing is the big disconnect, right? And then so not only do you have the clients that don't understand the terminology, but then you've also got vendors in the space that interchange the terminology as well, which you just described right there with the $5,000 pen test, quote unquote, versus the $75,000 pen test, which is actually a pen test, that actually requires a human behind the wheel and going through and testing stuff. So that's very interesting.
Yeah, I think the metaphor that I use to try to lay out the difference is I think metaphors are a great way to try to illustrate these really complex and confusing topics. And the one I use around this is I think about it around vehicle safety, like around cars. So a pen test, what a proper penetration test is it's actually saying, all right, well, let's take a built system that's already been through a lot of testing and let's see how it performs in a simulated scenario. And we're essentially evaluating a yes, no outcome. Like, did X happen? Yes or no? Mm-hmm. And so that's kind of like when the car maker wants to see how does the vehicle perform in a head-on collision. So what do? They literally crash the car into the wall. And so that's kind of like a pen test. It's a built system. It measures this very specific scenario, and it's already been through a lot of testing to get there. But when people are presenting a pen test that is actually vulnerability scanning, that's more like when the check engine light comes on, you go to the mechanic and they stick that little tool in under the dash, and it's looking for known codes from the onboard computer to say, oh, here's how you turn off the check engine light. Mm-hmm. So it's very quick, it's very easy, very inexpensive. It can only check for known issues. There's plenty of false positives, but it's certainly not the same thing as crashing the car into the wall, even though those are often used, the same words are used to describe both. But what makes it even more confusing is that what people usually need is actually something else. Now, not in all cases, I shouldn't generalize, but in most cases, when people are buying security testing, what they're really trying to do is they're trying to actually identify the problems, the security flaws. They want to know how bad those are. They want to know how to fix it. They want to then be able to fix it. And then they want to be able to prove it to their customers or whoever that, in fact, they have made this improvement. And that's more like what vulnerability assessments do. Vulnerability assessments are more like the department that is automotive safety engineering, right? They think more comprehensively, cohesively about the vehicle overall. Like, how do the airbags work with the side impact beams, with the lane departure technology? How do we make sure that the passenger survives an impact? And that's really more what people are kind of looking for. And so you look at those three things, and it's kind of like people are asking for pen testing. They're being sold vulnerability scanning, but they really need vulnerability assessment. How do we unpack all this? And my advocacy for that is start with the goal. Talk about what you want, not just I need a pen test, because you're probably not going to get the right thing, but say, this is the outcome I need. And if it's the outcome that lines up to a pen test, you get that. If it's the outcome lined up with a vulnerability scan, you get that. And if it's the outcome lined up with a vulnerability assessment, you get that.
Yeah, and I mean, that kind of goes back to my first question is the scoping and explaining the different types of approaches to application security and all that good stuff. And I think it is definitely on the client to kind of, again, I guess back to information sharing, telling you exactly what they're looking for, right? What are they trying to get out of the project? Because if it's just a vulnerability scan, or if it's just, hey, I want to identify the OWASP top 10 or whatever, yeah, you can do that. I'll just throw a scanner out here, good to go.
Right. Yep, exactly.
Call it a day, right? Plenty of companies do that all the time. So,
yep.
But yeah, when you talk about business logic flaws and all that good stuff, then you get into the deeper weeds. So we had a client that, sorry, Cash, go ahead.
No, go ahead. I
was just going to say, we had a client that, we were talking about terminology, and one of the things they kept throwing at us is like, yeah, we just want a lightweight pen test. And I was like, I don't know what that is. Like,
yeah, I've heard that so many times. Like, what?
Yeah. So we had like a whole call, like a 30-minute call. Like, can you define like what is a lightweight pen test for me? It's hard to.
They're like, I want the outcome of a pen test, but pay less.
Yeah, exactly. And I think that's really what that means.
Yeah.
So, the discounted rate.
That's so.
It's
funny.
like, I want lightweight marathon training. Like,
Yeah.
well, you either you're doing it or you're not doing it. What are you talking about?
Yeah. I've played Grand Theft Auto. I've run around I'm good. We could do the 5K.
Exactly.
So not, well, it's related to application security, but I don't know how comfortable you feel, but can you tell us a little bit like a fun pen test that you've done, something that was awesome without giving away the client that, you got in on something small and all of a sudden you're domain controller controlling a bank? I don't know. Like, do you have any kind of cool stories like that from your career?
Oh, I've got endless stories. Yes.
Yeah, share those.
Sure.
Let's share those.
We
Those
could
are the
just
fun.
we just do story time for the
Yeah.
rest of our time.
Sounds good to me.
Okay, well, this one's a little bit different than the way you frame the question, but I think the stories, I just like this story. So this comes out of research. This wasn't out of a paid engagement. We were really interested in looking at cryptocurrency wallets.
Mm-hmm.
And this was a few years ago. And so we were looking at a particular Ethereum wallet. And one thing that's really interesting to note about the way that these wallets work is that one of the key details that keeps them secure is this idea that cryptographers call statistical improbability. And it's basically the idea that you can't guess the private key. Like it's unpredictable.
Mm-hmm.
And that's a really, really important notion. And it's sort of statistical improbability essentially means that it's not technically impossible, but it's impossible. It's kind of like, if I went to the beach, picked up a grain of sand, threw it back, and then you went to the same beach the next day and you picked up a grain of sand, would it be the same one? It's possible, but not likely. And then you multiply that by like every beach on Earth and multiply that by a gazillion Earths. And that gives you the idea.
Like mathematically, it's like highly unlikely. Yeah. So they kind of deem it impossible.
It's basically impossible, but without, how mathematicians are, they would never say impossible. Right. It's impossible, but without being impossible. So, but the reason I'm putting that context around is that is the element that is really important to note, or one of the security elements that's really important to note about cryptocurrency wallets is that this idea of statistical improbability is what keeps them secure. You can't predict the keys. And we were doing some research that was exploring that idea in this particular system. And we found, in fact, that we could predict keys.
Oh, interesting.
So in the course of I think it was about 3 weeks, we actually successfully predicted the key 732 times.
Oh, wow.
Now, that's like picking up your same grain of sand on this interplanetary desert 732 times. You can't do it.
That's really
And so that was like cool on its own. Like, oh, you can't do this thing. We just proved you could do it. But we were curious to see, okay, well, how much money are we talking about here? And because it's cryptocurrency and it leverages a blockchain, we were able to actually look at the transactions, and we saw that it was a lot of money. It was the equivalent at the time of about $54 million was exposed across all these wallets. And, Ethereum, the volume of Ethereum has skyrocketed since. So it's like, I want to say it's maybe 15 times that value today. And I haven't measured that. I actually want to go back and measure that now that Ethereum's having its time.
Yeah.
But the point is, it's a ton of money. And so that begets the obvious question, it's like, it's almost like there's a pile of cash just sitting on the sidewalk. Someone's going to steal it eventually, right?
Yeah.
And it turns out that, someone did. Every single unit of currency in all 732 wallets had all been funneled to the single destination wallet.
Oh, wow.
And so clearly we'd stumbled upon someone's hacking all these other wallets, leveraging this same vulnerability that our research had discovered. And then the final thing we wanted to do was we wanted to see how quickly do wallets get looted. And so there's no way due to the anonymity of these wallets, it's not like we could call somebody. Right. So what we did was we took $1's worth of our own Ethereum and we sent it to one of those vulnerable wallets to see what would happen. And it was almost instant. The money was like instantly transferred to that central wallet. Huh. And so it's kind of nuts that in the course of research, we came upon an active hacking campaign, actively in process, that had already stolen at the time more than $50 million worth of currency. And it was really cool.
What was it about those 700 some wallets? Why? Because you mentioned that they've seem to have been accessed before from all of them pointing to a similar address. So
Mhm.
what was unique about those that
They
you were
all-
also, because it seems like from what it sounded like somebody else already attacked them, and then you guys were also able to get into it as well. So
Yeah, we discovered a flaw in the way that the keys were provisioned on these particular ones, and so well, I don't know for a fact that this thief was leveraging the exact same vulnerability that we discovered, but I have to believe it was the same thing, that all of them went to the same. It's like the likelihood that that's just a coincidence to me feels
Right,
feels
again,
impossible.
one of those mathematical improbabilities, right?
Yeah. So I think
And
this other group.
do you think
or
it was
individual-
limited to just those 700 addresses, or do you think there was other addresses as well that you hadn't discovered, but maybe someone else has?
I think there's way more. I think
Yeah.
the logical next stage of research would be to go then into that destination wallet and reverse engineer where did all other incoming traffic come from, and then go see if it existed in those. But then that's just one wallet. So this group or individual perhaps would have multiple of these wallets. And so, I mean,
yeah, I wonder if it's maybe like the wallet, the technology that the wallet was created with, because there's a different places where you can house your wallet, right? If all of them pointed to the same base.
Yeah, maybe, but
Right.
they should all be using the same blockchain. So I would think.
Yeah, no, the problem was with the software related to the wallet. It wasn't the blockchain.
Oh, okay.
Yeah,
So
yeah,
it
the
is the
software.
place.
Yeah, it's the
Got
wallet.
it.
Yeah, yeah.
Okay.
It was the wallet.
That's why I'm thinking it's maybe the whatever software that those wallets were created with.
It absolutely was the wallet.
Yeah.
Yeah, that was the problem. Yeah.
Awesome.
Software, man. Software is always. It's like I wanted to tell him. I'm like, how come Microsoft can never figure it out? You know, it's
Well, it's
but
because it's humans. Humans
Yeah,
make
it's
software, and
humans.
humans were flawed. We make mistakes. It's just complex, and I just don't see that changing. I mean, even as excited as people get around machine learning and artificial intelligence, it's like, okay, well, who builds the machines?
yeah,
Humans. Like, we're gonna inherently build our biases and our flaws right into those. So
for
we're gonna
now.
save time, but yeah,
And
for
then
now,
eventually they're gonna build themselves, and then we're doomed.
Yeah. Well, it's like thinking like a hacker, right? Most developers don't. No, most developers don't have that security background. So when they're programming, like back in my early days when I did development, I mean, we're talking early 2000s.
Mhm.
People talked about SQL injection. I was like, I don't know what that is, but sure,
Yeah.
I'll code it this way. And then, and then I learned what it was and how it worked. And I was like, oh, that's why I do what I need to do to make it, parameterize and all that good stuff. There's a couple different things you can do, but anyway, yeah, it's interesting. And I think that's part of it, as well. And you talk about that in your book as well, as the, developers need to have that training, that background, so they can think like a hacker, right? That's kind of the biggest thing for people in application security. So, well, and in security,
we want
period.
them to. It's hard. It's hard, right? It's like they're totally different disciplines. I think about it like you're the guy who builds skyscrapers, right? You're really good at building. You're the world's best at building skyscrapers. You could build them in your sleep, and then someone's like, you need to demo this other skyscraper. You need to be in charge of demolition. You're like, I mean, I could probably do some of that. But you're like, that's not my that's not what I do every day. I build things. I don't break them. And that's really the distinction. And I think it's such a ridiculously hard thing that we expect developers who are in the process of building things to also know how they're going to get broken. And that's why we really will forever need this sort of symbiotic relationship, this harmony between people who break things, ethical hackers, and people who build things, which are companies and the developers who work for them.
Yeah, definitely. And changing the mindset too, when you've got a team, and especially like the older generation who, they've been coding and doing things this way for years. And now all of a sudden they've got to do, change control, and they got to do, I don't know, peer reviews. I've honestly worked with companies that didn't use like version control on their code.
Oh, geez.
And so it was like a rude awakening trying to teach them how to use version control, and it's just amazing. And so, I think as this new generation comes into play, I think security will be more baked in, right? But up until that becomes a thing, I think we're still going to be kind of dealing with some of the past issues that we've been dealing with for the last decade or two. But and that was kind of one of the things too I wanted to ask you about is like, do you think security is getting better, worse, staying the same?
I was thinking the exact same thing.
I hesitate to give a simple answer to that. Not just because I want to make things harder, but because I think there are a few ways we could look at that. So do I think that when done right, the practice of security is improving? Yes, definitely. When I look at the companies that are more pioneering and understanding how security can become a competitive advantage, which is actually one of the main arguments that I make in my book and to anybody who will listen. I think it's a competitive advantage. I think it delivers a lot of really positive benefit to a company. I think for those organizations, security is improving. But I think overall security is at best staying neutral. If you look at like the entire population of companies who build things, and in some cases, it's probably getting worse. I felt really sort of depressed for a while about looking at what was happening with IoT and, Internet of Things, deploying all these with just like, it's like we just forgot about security. And we're just like, we're just not going to do security now in this emerging area of tech. And so that's kind of a bummer when you consider the rate of deployment of IoT devices.
Oh, yeah.
So I don't know which lens to answer that question through. It's either better or it's worse, depending.
Yeah, definitely, for sure. It's funny because on here, I've always joked about IoT and how you don't need a internet connected refrigerator with YouTube and Pandora.
Yet.
And I mean, I've done that. I've said that for years. And 3 weeks ago, I bought my fridge, a new fridge with internet, YouTube. And I read an article that said it was secure and this team had, attacked it. And yeah, we couldn't get in and we destroyed the fridge. But I'm like, it's still based on Android. Like, I get that you didn't get in, but like,
yeah, it's still
based on Android, and people are coming up with shit they're coming up with stuff all the time. You'll have to edit that one out, Cash.
I'll add the bleep.
Yeah. Anyway, good times.
But I'm saying here, I'm like waiting for all my house switches and everything to start like flickering on and off, and some guy come on the mic and be like, "I have control of everything."
Yeah, it's like that episode of Mr. Robot.
Yeah,
and I've said
that actually happened.
Yeah, it
to
does,
a member of my family. There was a baby monitor that that someone had hacked it and started talking through it, and, like screaming at the baby, swearing at the baby and stuff. It was It was so like violating of personal space and everything. But I think the real challenge when you think about stuff like this is we think about this and we're like, oh, okay, swearing at a baby, that's not that cool. Someone flickering my lights on and off, that's annoying. But for the most part, I think we think about vulnerabilities in IoT as like, well, that's too bad. But really, it's so much bigger than that. I mean, because first of all, IoT is more than just light bulbs and consumer grade stuff. It's cars and airplanes and it's devices that are being deployed in corporate networks, in government networks. And it's the way that attackers are mobilizing these botnets by taking over, like 100,000 cheap cameras. It's much more significant than what I guess is seen on the surface.
Right. Yeah. 100%. Yeah.
I didn't even think about it like that. His point to now there's all these like millions of little bitty devices that can turn into more botnets. It's not just like, oh, they're taking over these Windows desktops anymore, but that's pretty bad.
Yeah. Like it was a Mariah
yeah.
botnet.
It's exactly that.
Yeah. Yeah. I knew a guy who worked at a pretty big game developer and he was like, yeah, we put a webcam online. We just wanted to see if it would get taken over. And then they ended up calling us for an incident. And I'm like, well, I mean, play stupid games, win stupid prizes. Like, I don't know what to tell you.
That's actually hilarious.
But anyway, yeah. Well, thanks a lot, Ted, for coming on. And anytime you've got anything new or you got someone from your team that has some cool story, or if you've got another cool story to share, please hit us up because we're always looking for fun stuff like that. And for those listening, Hackable, available online, Amazon, in stores. I buy all my books online, so I haven't checked.
Yeah, I don't know.
Stores? I didn't know stores exist. It's just like Amazon.
So check it out. Learn a thing or two about application security. And for those that one executive out there that's listening, definitely pick it up so you know how to do application security correctly in your environment.
Yeah.
So,
And if anyone needs any, if this triggered any questions, follow up with me. You want to know where to follow me on social media, any of that stuff, I'm super easy to get a hold of. Just go to tedharrington.com. All my information's there. If you wanted to connect about even security testing or whatever it is you need, I want to be a resource. So just tedharrington.com.
Yep. And
Awesome.
hackablebook.com. And we'll throw all that stuff up on our podcast as well.
That's right. And then if you are still listening, please subscribe, like, hit us up, send us questions. We'd be more than happy to hear from you. And with that said, Ted, thanks again so much for coming out. And that's all I got. I guess I'll stop talking.
Thanks for having me.
Thanks for joining us. Take care.
Tavor out.